the old saying goes, you cannot see the tree from the forest. So you maybe have the problem of seeing the exact problem out of the entire big picture. My name is Darko, and today let's talk about AWS or observability on AWS. Actually, what are we going to be talking about today? Why are we here? Well, we're going to try to answer a couple of questions. What and why is observability? How can you implement proper observability practices on AWS? And maybe we'll answer the question, why or what am I doing in this forest? So let's begin. Actually, let's begin with our story. Every talk needs a story. Every time I talk about something, we need to, talk about someone. And we're going to talk about you. You are an engineer. You are a developer. You're an operations person in a company, big old global company that sells donuts. You sell donuts. You have a massive donut empire stretching across the globe from Tokyo to Sydney to London to New York. So what does that mean? Yes, the donuts are tasty, absolutely. But it also means that there's a lot of things to care about, right? You have multiple locations, multiple servers, multiple on-premises stuff. You have EC2 instances, you have containers, you have Lambda functions, you have IoT devices, you have mobile phones feeding data into your data analytics pipeline. That's very complex. All of these things are screaming information at you. But you come to me and say, well, Darko, I'd use DevOps. We have all the tools and safety measures to put things into place. Nothing can go wrong. Well, things can go wrong, right? So, and what does observability have to do with any of this, what I was talking about right now? Well, let me remind you of another story. My website is down. So some of you in the audience may know this. If not, check out, what is it called? A website is down. So this is a story about a web dude, an operations engineer playing a video game. And some person from sales, let's call him Chip, or actually his name is Chip, calls him up and say, hey web dude, the website is down. The web dude checks it out, it seems okay, but the Chip keeps on saying, hey, the website is down, it's bad, we need to fix it. So to make the long story short, web dude tears down the entire infrastructure because somebody told him the website is down, causing a whole lot of outage, whole lot of problem, well, for nothing. Observability can help, right? And you don't want your brain to go like this if you receive a 4 a.m. call from Chip. No. You want to have the ability to see things as they're happening and actually determine, is there a problem and what is the problem? So is that it? Is that all? Well, no. Observability also helps you in the thing we like to call the innovation flywheel. So what is the innovation flywheel? This is the thing in DevOps that you need to care about. You experiment, you try new things out, you listen to them, you look at what's happening. Has the change been better? Has it impacted your system in a good or bad way? And then you iterate. Observability here is key. Having the ability to see what's what, how does it look like, and does it behave as it should after this change? And then based on that, well, iterate, make it better, rip it out, or pat yourself on the back. With that, who am I and why am I standing in the report? Actually, why should you listen to me? My name is Darko Mesaros. I'm a developer advocate at AWS. I've been here for about 5-ish years. And I've been all the way from premium support, from solution architecture to now being a developer advocate to talk to you, our lovely developers and engineers. If you want more of this, make sure to check me out on the social medias. I have a lot of things on YouTube and Twitch, a lot of more content, even something in this exact same forest. So let's continue. So let's talk observability. Everything fails all the time. This is what our CTO, Dr. Werner Vogels, says. This means things go wrong, and you should be aware of them going wrong. So do not expect that, hey, I have all the checkpoints in place, I have all the pipelines, I have all the testings. Don't be so sure that that keeps you from failing. Things fail. Godzilla might walk into a parking lot and destroy an availability zone. She might go there and rip out your data centers, availability zones. You need to be aware that things can go wrong. So what do we do when things go wrong? Well, what do we do to know if things go wrong? We monitor. And a traditional monitoring system monitors all the things from network to OS to virtual machine layer to containers to hardware to application data to runtime to middleware, all of these layers are part of a traditional monitoring infrastructure. And I'm sure you have met a few of these, you've maybe configured a lot of them as well. But it's 2020. Monitoring needs to evolve. So, of course, we're monitoring these things as well to an extent in the cloud, right? But you also need to monitor different things. You need to understand how to evolve your monitoring. So from monitoring user experience, understanding, is the thing that's happening good? Right? Is it impacting user experience? Your resources are now short-lived. You don't no longer have this old server that sits there for 5 years. It's coming and going. So dynamically adding things to monitor is very important, and understanding what happens if you add them, what does it do? There's more services, more data, more things coming into your monitoring system, and you need to be able to determine what is good from all that noise. And last but not least, things are changing faster. More services are being updated. We are not changing software once every 3 months. We're making changes every minute, every 5 minutes, every 10 minutes. So much more often are the changes being performed right now than they used to be. So monitoring is more than just monitoring for failures. You have to understand a bunch of things. Is the service, is the workload you're running behaving as it expected? Is the usage okay? Because here's the thing, like for example, you're deploying an application and all of a sudden there's a CPU spike. You can go, oh, my servers are under load, let me add new things. But you need to understand that a deploy is happening and you don't have to freak out then, right? And also, is there a business impact? Your application can be monetarily, or according to your monitoring, can be functioning perfectly. It works. There's no high CPU load, there's no errors, but there's nobody using it. That's a problem. That's the thing you need to keep an eye out, right? So these are some additional things that bring into monitoring in the year 2020. So, but what is observability, Darko? You were mentioning observability, you're here for trees, you're in the forest. What? Well, 3 pillars of observability: metrics, logs, and traces. Of course, these things existed before even I said the term observability, but connecting these 3, understanding the context between these 3 is very important. Logs by themselves are great, but you do not know which log to look at unless you have a metric to point you at a specific time saying, hey, buddy, something was wrong at this time. The same as well. Looking at logs and metrics might not get you the entire picture unless you have some tracing involved. So contextual understanding of metrics, logs, and tracing is, well, in essence, observability. So putting these things in the observability pyramid, well, think of this. This is what will give you this will enable you to have observability practices inside of your environment. So to put it in a single sentence, having full stack visibility is basically observability. Don't quote me on that definition, but observability enables you to have full stack visibility while also being able to see the tree in the forest. Okay, now let's move on to talk about tooling. Let's talk about tooling. You remember that tooling pyramid or observability pyramid from a moment ago. What tools do we fit into these pyramid boxes? What is logs? What is metrics? What is tracing or traces on AWS? Well, simple. CloudWatch logs, CloudWatch metrics, and AWS X-Ray. So these are the tools and these are the services that you can use to enable some of the observability best practices on AWS. So let's start with you. How can you implement these things? What are these things that you should look into that enable you to, well, have a full stack visibility thanks to these services? With that, let's look at these 3 pillars that I mentioned before, and let's start with metrics, right? It's the first thing on the list. Let's start with metrics. So what are metrics? Metrics are the data on the performance of your systems. So this is the data your system emits somewhere to something about, hey, this is my CPU utilization. This is how much memory I'm using. I'm getting throttled. Oh, I have a high error rate. Or maybe I have disk utilization, which is up there, right? So this is that data that your system is telling you, hey, this is how I look like. And with the service called CloudWatch, I'm sure you all heard about Amazon CloudWatch. This is the service that actually enables you to gather that data, collect it, and do something with that data. Now, CloudWatch is not an exclusively a metric system. Not a service for metrics. It also collects all the data, including logs and other things. I'll get to that. It monitors. So this is the monitoring part of this. It can act on top of it. It can, first of all, monitoring, it can create those lovely dashboards. But when acting, it can create an event. Something has happened. Oh, let me trigger an automation to fix that. Or it can even do something more deeper or have a better understanding of why this has happened by using some analysis, some graphing and whatnot, right? So this is what CloudWatch enables you to do. And when we talk about metrics, there's a lot of built-in metrics. And I'm sure all of you who have been using AWS have seen this. From CPU utilization to credit count to disk I/O to the throttling to error rate to disk read writes to Lambda function invocations to, it's not just about EC2 instances. A lot of things on AWS actually emit data out. There's a whole list of services that emit data and what data they emit as metrics. So I'm sure you can find out. Actually, I'm going to put the link somewhere on the screen right now so you can see the link towards the CloudWatch documentation page. But yeah, that's fine. But you mentioned, oh, it's not just monitoring. It's not just CPU. It's not just, you said monitoring needs to evolve, right? Actually, yeah. So you can actually have custom metrics. You can instruct your applications to use our SDK to say, hey, here you go. This is my metric on how brown the wood is or how tall the tree is, right? So you can do all of those things. You can submit custom metrics, and then based off that metrics from your data, I mean, of course, the proper use case would be something like a business impact, number of website visits, or page invocation, or something like that. But again, you can be very creative with this, and you can add whatever you want. Your donut shop, you can add a metric, how many donuts per minute are being sold in your shops, right? So this is what you can also do. Okay, let's move on to logging. Logging is the second pillar of observability. Now, what is logging? Logging is the process of processing. No. Okay, no, not that logging. What's a log file? Log file is a file, a text document, where you write an event that has happened, hopefully with a timestamp, right? So in essence, logs are time-stamped records of events. So a log without a timestamp is just guesswork. So there's a timestamp saying, hey, at this time, this happened. So logs are very important. I'm sure all of you have met logs, have worked with logging in the past, because that's just what we do. It's the first thing you troubleshoot it, right? So what can we do for logs? There's CloudWatch. CloudWatch, again, is the tool of choice for this thing. You can funnel logs into CloudWatch. Why would you do that? Logs are useless if logs sit on the machine, of course. If you have a distributed system, remember your donut empire across the world? Are you going to log into every of those EC2 instances or containers to get its logs? No. You need to ship the logs to a central location. So having the ability to store the logs, put them somewhere, and potentially search through them and analyze them is key. Hence CloudWatch. CloudWatch logs is this ability to ingest logs from many locations, well, infinite amount of locations basically, into CloudWatch, do something with it, or even you can export those logs to somewhere else, to an Elk stack, right? To your Elasticsearch, Logstash, and Kibana, or push them to an S3 bucket, or process them with Lambda functions, or even put them to a Kinesis fire hose and put those logs somewhere else for further processing. So CloudWatch is not the only thing that can do logs here. CloudWatch can be an entry point of your logs and have them funnel somewhere further. So, like with normal logs, of course, you have those existing logs from your services using the CloudWatch agent, but what's important, you can also enable your applications to directly write logs into CloudWatch. So it's not something you can depend on, like your application, oh, I'll write it to a disk and have CloudWatch move it. You can actually directly write from your application into CloudWatch. Think of Lambda functions. This is what Lambda functions in essence do. They write directly to CloudWatch. So there's no agent, there's nothing. It's written directly to CloudWatch. So this gives you a flexibility to write anything into a log if it happens. All right, last but definitely not the least, tracing. Tracing is this thing that's not oftenly used, or I would say in my world, I have not met tracing in my line of job a lot, but I used to work in more traditional companies. But tracing is this ability to have an end-to-end view of a request flowing through an application. So you have a user in New York, request a donut subscription. What happens with his click? His click goes from the website to checking his balance, to checking, do we have donuts in offer right now, to confirming that thing, to writing something to a database, to sending a notification to the local bakery to make those donuts. And X-ray, or tracing, enables us to do that. And speaking of X-ray, well, X-ray. AWS X-ray is the tool of choice for a distributed application, for a tracing through a distributed application. So you can identify what is happening, how does your little request look like, and it generates these lovely service maps. It gives you drills down into how long things look like, how long things took, and it's an amazing tool for understanding bottlenecks, what is taking so long, and at the end, what can you optimize? You remember that innovation flywheel? Yeah, so you make a change, you look at X-ray to see, oh, wait, my API calls are taking twice longer now. I made bad code. Let me revert it back and make it work better, right? So it gives you these, again, lovely service maps where you create a simple service and just have a map of a request going through that from one Lambda function to another, to a DynamoDB, right, to whatever, right? It's wonderful. It gives you this amazing overview. And if you want more deeper information, you can actually look into a specific invocation, specific trigger on what took how much. And yeah, you can see all of those tiny little details. You will see all of your Lambda cold starts and your cross-region writes, which are potentially not the best. But yeah. So how do you implement tracing? How do you actually enable tracing on your applications? Well, you can have, let's have a look. So we have a Lambda application here. It's an application that's a simple. It's a simple shop application. It's a cart application written in Python in this case. So how do you do this? Well, it's a bit complex. You need to enable. First of all, you enable X-ray on your Lambda function. There's a checkbox, right? But also you need to add some code to your code. You import the X-ray SDK core. You record some work, something that has happened within your Lambda function. You basically return that work. Then you add metadata. You put some metadata into a response, and also if something happened, for example, if there was a cold start, you put more annotation saying, hey, there was a cold start. And do that again, and again, and again. For all of your functions, all of your work, you put these things in. That's complicated, right? It takes a lot of effort. What if I told you we can do the same thing in 1, 2, 3? Okay, let's go. 1, import AWS Power Tools for Lambda. 2, initiate the tracer. 3, I cannot do that 3. Enable tracing for the handler. Voila, that's it. We have AWS Lambda Power Tools, a lovely framework, lovely set of tools that has all the bells and whistles to enable not just tracing, but logging and metrics for your applications. It supports Python and Java at this moment, but it is just a wonderful thing to work with. For most of my Lambda applications that I work with, I enable Lambda Power Tools just because it makes it so much easier to enable all of these things much simpler. And again, it's just a matter of adding 3 lines of code. Okay, now, using Movie Magic, we're gonna switch on to a demo right now. I'm gonna actually teleport back to home because I cannot do a demo in the forest. Wi-Fi is crappy here. So let's actually move on back home, and I'll come back here to wrap it up. So, welcome to the future demo. This is actually a few days after the forest talk, as you may not notice that this is not a forest. So let's have a look at some demo, something that we can actually touch and see where observability practices are applied. So we're somewhere where we have logging, metrics, and tracing as well on a single application. So what I'm going to be showing you right now is a serverless application augmented with AWS Lambda Power Tools for Python to include all of those things. Let's have a look at the application first. So the application is just a simple shopping cart style of application. It has a demo store. It's a demo store where we can buy produce. So let's actually do something. Let's click candied prunes, some fresh lettuce, a bunch of fresh tomatoes,
Let's do some strawberries because strawberries are really nice. Let's just actually just remove some tomatoes and some steak. Go to the cart, that's $50. Click here, card number is gonna be, doesn't matter, just a bunch of zeros. It's me, the expiry date is 1111 and the 123. Right, perfectly viable credit card. Click submit, and this is where the payment happens. Our application has run its course. Now, let's actually have a look at the application itself. So we are actually using AWS Lambda Power Tools for Python to introduce logging, tracing, and metrics to our application. This is actually a sample application that comes with Lambda Power Tools for Python. We'll do a bunch of things here. So let's have a look at some code. Actually, let's have a look at the code in a proper terminal. So right now, I'm currently within my serverless application repository. So if I go to backend, or actually let's open up Vim, and then let's go to backend and shopping cart service, and we can go to the checkout cart. One of the things you will see here is that we have line 5 AWS Lambda Power Tools. We are importing logger, metrics, and tracer. Then we are actually instantiating those things, instantiating the logger into a variable, metrics into a variable, and tracer into a variable. And then simply as that, adding a debug line to the logger, also logging metrics for cold starts, for example, injecting Lambda context into the logger. And for the tracer, the big important thing for our X-ray part, we're actually capturing the entire Lambda handler. We do a bunch of other things here. If we go scroll down here, we will see, for example, on the logger, we're adding some action information. We're adding a metric for a cart checked out. So we're creating a custom metric here with this, just with a single line of code. And yeah, it's a relatively simple, streamlined way to get these things enabled on your serverless applications. Now, if we go back to here, when it comes to metrics, to traces, the very important thing, we can actually have a look at our cloud AWS X-ray. Now, AWS X-ray here, what it does, it actually created a service map for our application. One of the things you can see here, I have a client, and if I would refresh this right now, let me do that, we will see the service map for this service. It would compute all the elements of the serverless application and its relationships between it. So that would be too big. Let me actually do it like this and zoom in like so. One of the things, for example, we can see how long each of these elements took, each of these Lambda functions or DynamoDB table writes, or a bunch of other things that are happening here. For example, an API gateway call, we see that this is how much the response, this is how the traces basically look like. We can potentially find some bottlenecks in our application, like, for example, we have a 900 millisecond bottleneck here on this Lambda function. Something is happening. If I click on view traces, I can actually view the entire trace here to see what is actually taking so long. It had an initialization of 628 milliseconds. This is most likely a Lambda cold start, and the actual Lambda handler took only 0.4 milliseconds. So we can kind of deduce things that why have certain things happen here in this specific Lambda function. Now, let's move on to logging. We can have logs. So if we go to CloudWatch logs and I would like search for, let's do cart, I can see the checkout cart function here. Then I have a bunch of Lambda function logs. Now these are not just on your standard run-of-the-mill Lambda function. Hey, it invoked, this is the length of the invocation and all that stuff. Because of the logger functions, we have a lot more information here. We can have, location, service, basically a lot of more information being added to our log file rather than just, hey, the Lambda function has been invoked. So of course you can do all of this without Power Tools, but it makes it a bit easier with Lambda Power Tools, right? So as you can see, a lot of information coming here, a lot of things we can correlate and make something out of in a proper observability fashion. And last but not least is definitely the metrics. So for example, if I go to metrics right now, let me go here. Where is my metrics? All metrics. I will actually be able to see that I have a custom namespace called e-commerce app. That is the custom namespace generated by my Lambda function, by my serverless application here. If I click on this one, I can see the service and even some function names. So if I click on service, for example, the shopping cart service, I can have two custom metrics called cart updated, cart checked out. These metrics would increase or change value in the amount of people that are using this application. Now, as this is a sample application running on my own account, well, just recently, there's not a lot of invocation, but we can also see on other things here as well. For example, if we go to a specific Lambda function like shopping cart checkout, we can see actually how many cold starts did it have in the last X, Y, or Z, right? So we can see that information as well. So if I remove the other ones, for example, let me move these things, I will see the number of cold starts that have happened in the last, today, last half an hour. So this is also an information we can gather from here directly as part of the metrics collected by the Power Tools. And if you recall the piece of code, this is the piece of code that says, hey, add that, we have a cold start metric, that's the cart checkout, but here it is, line 20, capture cold start metric. So this is what will create the cold start metric. Again, you can create any kind of metrics. This just makes it so much easier to do with Lambda functions. And yeah, that would be a simple way to implement this using AWS Lambda Power Tools for Python. It's all available on the GitHub page, so AWS Lab/AWS Lambda Power Tools Python, and there's the sample application there as well called serverless shopping cart. All of these things are actually built with Power Tools in mind and with all the best observability practices in place. That being said, I think we can go back to the presentation and slowly wrap it up. So, past Darko, here's to you.
Back in the forest. Okay, hope you enjoyed that demo. Hope you learned something. Okay, so lastly, the final slide of the day is takeaways. Of course, you need something to take home. This is the things you should remember from today. Number one, observability combines metrics, logging, and traces into a single thing. Well, it creates contextual connections between those three. It's important to gain full stack visibility with all of those things. Also, make sure that the workload you're running is emitting the right information. If it's missing something from the built-in metrics, built-in logging, built-in traces, make sure to add those things because you want the right information out there. Why do you want that information out there? Because monitoring is not just measuring for failures. It's also understanding, is the system behaving as expected? Are the orders coming out? Are the donuts being sold? What is the usage? Has the number of orders of donuts gone down because you made a bad change? Or is it up? And also, is the business impact? Is the business all of a sudden losing money because one part of your application is calculating VAT a bit bad? Observability is very important. It enables you to see the tree from the forest. Why am I in the forest? I just wanted to make a stupid pun by saying that joke. So there we go. My name has been Darko Mesaros. I really hope you enjoyed this presentation. I love doing these things in the forest. My laptop is currently on a stump. I'm looking at it. So hope this was well worth it. Yeah, feel free to send me any feedback and make sure to follow me on the social medias or for more content. And do let me know if you enjoy this type of presentation. With that being said, I need to hike back home and thank you all. Bye-bye.